So just continuing on from last time, let's take a look at that one to the right that we did to end class last time. What do we need to do first? Look for a GCF. So I'm looking at the 3, the 17, the negative 17, and the 20. Is there a GCF there? No. So I don't have a GCF to factor out. Do AC is 60. So now what am I looking for? So I need two numbers that multiply to give me 60 and add to give me negative 17. They both have to be negative, that's right, because they both are going to multiply to give me a positive. That means they're either both positive or both negative, but they've got to add to give me a negative number, so I'm looking for two negative numbers. That thought process makes picking these numbers a little bit easier. I'm going to add two numbers together to get 17. Negative 3 and negative 20, but I got to add those together and I get negative 23. Negative 12 and negative 5. Negative 12 times negative 5 is positive 60. And do those add to give me negative 17? Yeah. So if you do that little sign thing there and figure out that you have two negative signs, then it's easier to come up with the numbers. We got it very quickly. Otherwise, there's a ton of factors that we got to look at with that positive 60. So check to make sure. This is the only time you have to check to make sure that your numbers are correct so far. Once you write them down, negative 12 times negative 5 is positive 60. Negative 12 plus negative 5 is negative 17. So I'm good. Now what? Draw the box. Okay, now what? First box, first term, 3x squared. So that's 20, and then, okay, so the box is set up. What am I doing with my columns and my rows? Not just the common factor. You have to find the greatest common factor. It has to be the greatest, otherwise this process does not work. So, for my top row, what is my GCF? It's just x. The greatest common factor of 3 and negative 5 is 1. There's no number that goes into both of those except for 1. So we have 1x or just x. How about the bottom row? Yeah, it is 4, but that first box was negative, so we got to call it negative 4. And now my first column. 3x is correct. And then my second column. Yeah, it is 5, but since that first box here and that column is negative, we got to call it negative 5. Now what? Yeah, the problem's over. We just got to go with our FOIL problem. We have 3x minus 5, that's coming off the top here, times x minus 4, which is coming straight off the side that we factored out over there. That is the answer. Okay, next one. What do we do? Is there a GCF here other than 1? No. And the numbers are really, really small, which is going to make this problem kind of maybe tricky. Some people, when they have small numbers like that, they get kind of confused. So what do we do? AC equals, yeah, it's negative 2. So now we need what? Two numbers that multiply to give me negative 2. Add to give negative 1. There's really only a couple options here. So 2, if we try 2 and negative 1, 2 and negative 1 do multiply to give me negative 2. But positive 2 plus negative 1 gives me a positive 1 here. So that one doesn't work. It has to be the opposite signs. Negative 2 and positive 1. I know. I'm just explaining it. Okay. So we have negative 2 times positive 1, which is negative 2. Negative 2 plus 1, which is negative 1. So those are the correct answers. The nice thing about very small numbers is there's not a whole lot of choices. We really only had 2 choices. Now we can set up our box. What am I doing? Yep, first box, first term, 2n squared. Last box, last term, negative 1. Negative 2n, 1n. The variable here is n. That's not a big deal. We can use any letter we want. So just stick with the letter they give you. Now what? So for my top row, 1n, or just n. Negative, what? It's just negative 1. There is no n in this box. Because we don't have an n in both boxes, we can't pull an n out. The more problems you do like this, the more you'll see that the pattern shows that this one's going to have the n, this one's just going to be a number, like pretty much every time. The GCF of 2 and 1 is 1, but that front box is negative, so I got to call it negative 1. First column, what do we have? 2n. And second column, just positive 1. This is a negative 1 down here, but that doesn't matter. This first box was positive, so our factor is positive. So what's the answer here? What if I had written n minus 1 times 2n plus 1? Would that be okay? Yeah. Either order on those factors is fine. I'll know the difference, and I'm not going to mark it wrong. But I will mark it wrong when your signs are wrong every single time. So you need to check your answers, always. We could FOIL that back out. If we FOILed it back out, we would get exactly that. If we FOILed it back out and we didn't get exactly that, what should we do? Find your mistake. If I look in the back of the book and I don't see my answer, what should I do? Find your mistake. That's how you learn. All right, this fourth one is yours. Go. Let's move quickly through this one. What are we doing first? GCF is 5, so I have 5 times plus 6. Good. And now I need to, AC is 12, so that means I need 4 and 3. But they both got to be negative. 4 and negative 3. Now no, yeah, I got to check them. Negative 4 times negative 3 is positive 12. Negative 4 plus negative 3 is negative 7, so I'm good. Now I box. First box. Yep. 6 in the last box. And then good. Doesn't matter on the order there. Okay, first row. Yep, 1y, or just y. Bottom row. Negative 2, good. And first column? 2y. And last column is negative 3, good. So my answer is, don't forget your GCF, 5 times 2y minus 3 times y minus 2. Good. Now, as I'm going to check that problem, the first thing I want to do is FOIL. Then I'll have the 5 times the trinomial. I distribute that 5 back in, and then I should wind up with the exact same thing that I started off with. This is the correct answer right here. Story problem type situation. The area of a rectangle. I'm not even going to continue reading. As soon as I see that, what should I do? Draw a picture. Draw a rectangle. Maybe it'll help me, maybe it won't, but at least I'll see it. Okay, the area of a rectangle, all right, area. How do you do area? Right, so I got to multiply this side here times this side here to get the area. And then they tell me, I haven't even finished the problem, I already know all that stuff. The area of a rectangle is this. Here's my area right here. So that means I must have multiplied 2 binomials together probably to get that area. What are the possible dimensions of the rectangle? And then again, this use factoring thing. What are we going to do here? Yep, use the box method basically. How come I know it's got to be the box method? It says use factoring, but how do I know I'm going to use the box? Because I do have a trinomial, but more importantly, It's the number in front of the x squared term that's there. It's not a 1. As soon as there's a number there, I'm probably going to have to use the box method. So what's the first thing we do here? Look for a GCF. There isn't one other than 1, so we move on. Now it's AC. Okay. -1. I got to have two numbers that multiply to give me -14. They got to add to give me -13. Yes, it's got to be -14 and +1. They have to have opposite signs because this is a negative number here. When I multiply them, I got to get a negative. -14 times 1 is -14. I got to add them to get -13, so the bigger number has to be the negative number. So it's got to be this guy. All right, now we can what? Set up the box. First box. 2x squared, last box. Okay. There you go. First row, x. Last row. Good, -7. First column. 2x. Last column. Just 1. Can't pull an x out of there, and it's a positive, and the biggest number that goes into 1 and -7 is 1. So there you go. So that means my answers are... Okay, so it doesn't ask me to do this, but let's do it anyway. The left one or the right one? Which one is the length? Yeah, so x here and here is going to be the same thing, right? And the length is usually the longer side. So I'm trying to figure out which one that one is. Which one of these is longer? Well, on this one I'm doubling the number and then I'm adding to it. On this one I'm just taking the number and subtracting away from it. So this one must be smaller. So the problem doesn't ask you to do this, but we're going to do it anyway. This has to be the 2x plus 1. And this has to be the x minus 7. It's just nice to know that you can do that, just in case the problem asks you to do it sometime down the road. So that is it for this section. That's using the box method. You use the box method when you have a number in front of the x squared term, but just remember to factor out the GCF first.